So now that we proved the distance formula, let's actually apply it to assist us with finding the distance. So we can see the distance formula above, and now we're asked to find the distance between the points -5, 7, and 9, -1, which means that this is the coordinate x1, y1, and this is the coordinate x2, y2. And so what I do is I just plug them in the formula and solve for my distance. So my distance is equal to the square root of x2 minus x1. So it's 9 minus a -5, so 9 plus 5 squared, plus y2, which is -11, minus y1, which is 7 squared. And so really, 9 plus 5 is 14. So I have 14 squared, and -11 minus 7 is -18. So I have -18 squared. So my distance is equal to the square root. 14 squared is 196, and -18 squared is a positive 324. So I add those numbers and I get my distance is equal to the square root of 520. As mentioned in the previous example with proving the distance formula applying the Pythagorean theorem, we're not going to worry about simplifying the radical. We're just going to go to our calculator and type in the square root of 520, hit enter, and I get 22.803. So if I round that to 2 decimal places, my distance is equal to approximately 22.80. And so there's our distance formula. Let's try another example with this. So we're asked to find the distance between the points 4, 4 and -6, -2. So as always, go through and see, well, that means this is my x1 and this is my y1. This is my x2 and this is my y2. So distance is equal to the square root of x2, which is -6, minus x1, so -4 squared, plus y2, which is -2, minus y1, which is -4 squared. Well, -6 minus 4 is -10. So I'm squaring -10. And then -2 minus 4 is -6. So I'm squaring -6. So -10 squared is 100. And -6 squared is 36. So I have square root of 100 plus 36, which is the square root of 136 when you add them together. And so like before, I go to my calculator, let me clear out what I had before, and type in second square root of 136, enter, and I'm going to get 11.6619, so rounded 2 decimal places, and we get our distance is approximately 11.66. And so that is the distance formula. The only thing, a little piece of advice before we move on to the midpoint formula is right here. The thing you need to be careful with is if you're going to use your calculator at this point, which really you shouldn't need to. If you're in Algebra 2, you should be able to square 10 and 6 without calculators. However, if you can't, notice how I wrote it down. I put the negative inside parentheses. And I'll pull up the calculator and show you why as one little warning before we go, is by putting the parentheses around the -10 and then squaring it, I am following order of operations. I'm taking -10 and squaring it, so I do my exponent first. -10 squared is a positive 100. But if I do not put a parentheses around it, and I type in -10 squared, the calculator follows order of operations. Negative coefficient really means there's a -1 times 10, and then you're squaring it. So it's going to do the exponent first. It's going to square 10 first, and then work with the negative. So if I hit enter here, I get -100. So my piece of advice is this. You have some number sense at this point in your career with mathematics. You should know when you square a negative, it becomes positive. So if you ever type something in like this, it should, don't follow the calculator, it should make sense to you. Well, that doesn't work. I know a negative square is positive, so I'm just going to ignore the negative sign and write down 100. So that's my piece of advice, is my notation in the work whenever I had a negative is proper notation. And it's the way you should even type it in your calculator to get the right value.